Okay, this video is circle basics, and we're going to find the circumference and area of circles. Objective, we'll apply the formula for area and circumference of circles and calculate the diameter using Pythagorean theorem as needed. Alright, so here are the basic parts of this circle. We have, let's see, the radius right here. The radius goes from the center of the circle to any point on the side, and so C is the center. This point here, E, is just an exterior point. It is not in the circle. And then interior points would be like I is an interior point. That point is in the circle. And then this line segment, DB, is the diameter. And the diameter is twice the length of the radius, and it goes from one point on the circle to another point on the circle, and it has to go through the center. And it is the longest chord, that's called a chord, of the circle, but the diameter. All right. So here's some definitions. All points. Okay, so the definition of a circle is all points that are equidistant from a given point. In other words, any point on the circle is the same distance or the radius from the center. It separates the plane into three sections: interior, exterior, and the circle. AC, let me look at my picture again. Okay, AC is the radius. And it has one endpoint on the center and one on the circle. And then the diameter is a segment that goes through the center with both endpoints on the circle itself. Okay. So here we have a picture, and what we're going to do is just name the different parts here. So if you want to name a circle, you name it by the center. And you would just draw a little circle here, put a dot in the middle, try and put it right there in the middle. Let me try that again, like this, and it would be circle Q. Just name it by the center. The radii, which is plural for radius, is we have PQ, and we have QT. So those are line segments. And then what is the length of any radius of the circle? Well, they tell us that this is 16, so they are all the same. What would be the length of the diameter? Well, the diameter is always twice the radius, so it would be 32. The interior points in that circle, the center is an interior point. We could call Q a point, we could call R, and we could call S. The points on the circle itself, you do not call those interior or exterior. The exterior point, the only one that we have here is X. An exterior point has to actually be outside of the circle. All right. Let's see. In this picture here, we're just going to name these parts. All right. So, there's some new definitions here. This line, let me see, this line right here that goes through the circle is called a secant. Okay, a secant goes all the way through the circle. Now DB, where it begins and ends on the circle, this is called a chord. And then this line right here, where it just touches the circle at one point, is called a tangent line. And the point where it actually touches the circle here at T is called the point of tangency. Okay, so these are just new definitions that we need. Secant, chord, tangent, and point of tangency. So now let's fill in the definitions. A chord is a segment whose endpoints are on the circle, and then the diameter would be the longest chord. A secant is a line or ray that intersects the circle at 2 points. A tangent is a line segment array that intersects the circle at exactly 1 point. And the point of tangency is the intersection of a tangent line and the circumference. So in other words, if we have a circle and you have a line, it should just touch, and that point where it touches is the point of tangency. So let's look at some examples here. All right, so in example 2, we're going to name the different points from the circle. So the center is a point, so it is just a capital O. Name the radii. So we have NO, we have OR, and we have OM. Those are all radiuses because they go from the center and they touch the circle. Now the chords are, well, we have, let me use a different color. The longest chord here is a diameter, MN. But we also have this chord right here. Now this is kind of, let me show you. MT is a chord if we write it as a segment with the beginning and an end. Okay, if you look at the, if you want to say that it goes on forever, then that's a secant. So we can call MT that continues through the circle as a secant. But we can talk about just part of it. This part would be a chord, but then we have to acknowledge that it begins and ends. So the diameter is MN. The tangent, we're going to look at this line right here. So we can call that PS, or you can call it QS. Any of those 2 points will work. And then the point of tangency is this point where it touches, Q. All right. So now we have our formulas. So the circumference of a circle is 2 pi r, or pi times the diameter, because 2 times the radius is a diameter. Usually this is the formula that we see on formula charts, 2 pi r. And then the area is pi r squared. So when we're doing these problems, we want the exact numbers, so you're going to use pi in your answer. All right, so example 3, we want the circumference and the area. So we look here and we have a triangle, a right triangle, where both sides or both legs have the same length. So you should know that that would be a 45, 45, 90 triangle. So if each side is 16, the diameter should be 16 times the square root of 2. So here in this case, the circumference is 2 pi r. So 2 times pi times the radius. Well, the radius is half of the diameter. So 16 times the square root of 2 divided by 2 is 8 times the square root of 2. So 2 pi times 8 times the square root of 2. You're going to multiply 2 times 8. You're going to get 16 square root of 2 pi. We can put that in our calculator and get an approximate. So let's see. 16. Sorry, my calculator's a little... That's 71.1. Okay, now the exact area. Well, the area is pi r squared. So the radius, again, was 8 to the square root of 2. So it's going to be 8 to the square root of 2 squared times pi. So if we do 8 to the square root of 2 times 8 to the square root of 2, remember you're going to multiply 8 times 8, 64. The square root of 2 times the square root of 2 is 2. And then 64 times 2 is 128. So this is 128 pi. And if we put that in our calculator, that is approximately 402. All right, so try and do the quick check. On this one here, we have a square that's drawn inside this circle. So each side is 8. So that would make the diameter 8 times the square root of 2. So our formulas for circumference, 2 pi r. So if the whole side is 8 to the square root of 2, half of that is 4 to the square root of 2. So that's our radius. So 2 pi times 4 to the square root of 2. You're just going to multiply this 2 times the 4, and you're going to get 8 to the square root of 2 pi. Approximately, I'll use my calculator. Sorry. And that is 35.5. All right, so the exact area is pi r squared. So 4 times the square root of 2 squared times pi. So remember, 4 to the square root of 2 times 4 to the square root of 2. You're going to multiply 4 times 4 and get 16. The square root of 2 times the square root of 2 is 2. And then that is 32. So we have 32 pi. And then in our calculator, that is approximately 100.5. All right, let's look at the next example. Here we're going to have to use Pythagorean theorem to find the diameter. All right, so 10 squared plus 24 squared is equal to c squared. So 100 plus 576 equals c squared. So 676 is equal to c squared, and the square root of 676 is 26. So c is equal to 26. So let me erase these parts here. So this is 26. So that's the diameter. So the radius is half of that, or 13. So my radius is 13. And so I have 2 pi r. So 2 times pi times 13 is 26 pi. We can put that in our calculator in a minute. Let's do the area because I'm about to run out of time. Pi r squared. So pi times 13 squared. So that is going to be 169, I think. Yeah, 169 pi. And if I have time, let me try and get my approximates. 26 times pi is 81.7.